Hello dear student, how are you? I hope you all will be fine. I'm also fine, thank you. Welcome to HND Science Group. Let's start today's topic. Today I bring a new mechanism of carbylamine reaction that is very important, very important in organic chemistry, very important mechanism, organic reaction mechanism. So let's start the topic without wasting of time. And this mechanism, carbylamine reaction, this mechanism, one chloroform will be take one chloroform will be used as a substrate in the initial reactants, and they will be treated with the alkyl amine. When they are treated with the amine or alkyl amines, after the alkyl amine treated with alkyl amines, they will produce the isocyanide structure, isocyanide, or this is also called alkyl cyanides. So let's start the mechanism. Okay, mechanism. Here is Cl, that is one chloroform, CHCl3, that is structure of chloroform, and in this mechanism and in this reaction strong nucleophile will be used, strong base will be used, like that is KOH or NaOH, that is KOH is strong, very strong base. So KOH will be used in this mechanism. That is OH, when we write here is K and OH, after the decision of KOH, after the decision of this base, the K will be produced K plus, and OH will be generated into OH negative. So that's why this OH negative can abstract a proton from this chloroform. So that will be abstract a proton, this will be attack on this proton. So that's why this bond will be shifted toward carbon, and carbon will get negative charge, and it will be generated into, hydrogen will be leave as a proton, or it will be generated into water, it will produce water. So here in this case, that is one tetrachloro compounds of carbon. They means 3 chlorine are bonded with the one carbon. So here in this case, the one proton, the one potassium that was ionized from the KOH from the base, that will be abstract a one chlorine atom. So that's why potassium will be bonded with the chlorine, and it will generate into singlet carbene. Mean this bond will be shifted here, and here it will be one lone pair remains. So that's why singlet carbene will produce. Now this singlet carbene will be take part in the further reaction. It will be react with the alkyl amines. So the reaction will be like that. That is alkyl amine. That is one alkyl amine. So here in this singlet carbene, you should know that the structure of singlet carbene is and you should know that carbon have four vacant orbital. That is one vacant orbital that are bonded, that are not vacant, that are bonded with this chlorine, and one vacant orbital that are not vacant but this are bonded with this chlorine, and one vacant orbital that are not vacant because they have lone pair, and one vacant orbital that is really vacant. So here in the singlet carbene case, so that's why this lone pair will be attack on this vacant orbital. When they are attack on this vacant orbital, it will be produced like this structure. Let's see the structure. That is NH2, that is NH2, that is NH, and R is remains same. So that's why nitrogen bond between nitrogen and carbon will be produced, this carbon between, but here in from lone pair of electron transfer from nitrogen to carbon. So that's why carbon will be get negative charge and nitrogen will get positive charge. So that's why it will be produced negative and positive charge, but here 2 chlorine is present, sir. But in the further steps, we should need to abstract one another proton from the thing to create another bond between carbon and nitrogen. So that's why we should need to use another base from the solvents, a strong base that will be abstract this proton. After this proton, this bond will be shift here, and here will be double bond producer, and when the double bond produces, one bond between chlorine and carbon will be broken, any one of either chlorine. So that's why the below chlorine will be breaks, and a producer here is bond between nitrogen and carbon. Here is double bond producer, and one hydrogen will be lost by this one hydrogen of nitrogen will be abstract by this hydroxyl group or by this strong base. So that's why here is one chlorine remains, and one chlorine will be go away towards with potassium, and so they will produce potassium chloride. But here in this case, once again the same mechanism repeats. One another strong base will be attack on this hydrogen. As when they are attack on this hydrogen, this bond will be shift here, and here is triple bond between nitrogen and carbon producer. So that's why the bond between carbon and chlorine will be break down, and it will be go away with potassium as a potassium chloride. So here is new compound will produce, that is the R, that is triple bonded with, R is bonded with nitrogen, and nitrogen is triple bonded with carbon. So here is one plus charge and one negative charge. So is a whole atom, you can say that it is a neutral because of positive and negative charge. So you cannot show, in general you cannot show the charge. You will directly write that RC and R and C. You will be directly write R and C. That is isocyanide. That is also called isocyanide or alkyl cyanide. So this is alkyl cyanide. Or you can also represent the structure, this formula, and that is R bonded with nitrogen and that is carbon. Because of the lone pair of nitrogen will move towards carbon, and they bonded with between carbon and nitrogen. So that's why we can say that that is coordinate covalent bond, and we can draw with the arrow. So this is the isocyanide structure, and that is this result of the what CarbylAmine reaction. I hope this mechanism will be clear. Still, if you have any confusion, if you have any question, you can ask me in comment section, as well as you can ask me in my personal WhatsApp or Gmail that I put in the description box. You can get from there. Okay, thank you very much. Very best of luck. Very best of luck. Also, please subscribe my channel. It makes me feel happy that you are supporting me. Okay, thank you very much. Very best of luck.